Hi, so I'm going to go through the answers for the extension questions if you attempted them. Remember, they're optional. Here's the quick answers here. If you don't want to go through all the solutions, if you've got them right, you can just quickly check. The first one, remember D and E, I've asked you to do it one way using a graph and then another way using an equation, so you should get the same answer. And the same for question 8, D and E, and then F and G. So let's work through solutions if you want solutions, but A, these are optional, and B, if you've got the answers right, you probably don't need to go through the long version. Up to you. Why is this up here? All right. A student drops a rock from the top of a 30-meter tall building. The first thing that I haven't explicitly told you here, but because this is an extension question, you should know, is that gravity, the acceleration due to gravity, is, let's just use 10 meters per second for every second. All right, but we'll get back to that in a second. All right, let's make a well-labeled diagram. So here's my building, and it's 30 meters tall. And there's a person, and he drops a rock. Make a well-labeled motion map for the situation. Label the origin and the positive direction. What I think I might do here is I might make my motion map, and you can do this with your motion map. You can make it any direction you want. Here's my building. I'm making the origin where the rock starts from. So there's 0, and I'm making my positive direction down this way. So the rock is close together and gets further apart. So little arrows, bigger arrows, bigger arrows. Velocity, 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 and in between is acceleration. So the acceleration arrows are going down this way. So the great thing about the motion map, it gives me a clear idea of what's positive, what's negative. In this case, because I've chosen my motion map this way, velocity and acceleration are both positive. So my acceleration is positive 10. Draw a position time graph and a velocity time graph. Well, it starts off at the origin, it starts off at 0, and it gets faster and faster and faster. And I'm just going to move this. Velocity time graph, it starts off with 0 velocity and it gets faster and faster and faster at a steady rate. That steady rate is the gradient, which is 10. Use your graphs to find out how long it takes for the rock to hit the ground. Now, this is a tough question. This is why it's in the extension questions. The time it takes for the rock to hit the ground. All right, what do I know? I know, here's my velocity time graph. Let's say it hits the ground at this point here. A 30-meter tall building. So I've got 30 meters. Displacement of 30 meters. What does that look like on my graph? That's the area. So I know the area of this graph is 30 meters. I also have the acceleration. What is the acceleration on the velocity time graph? That's the gradient. So I know the gradient equals 10 meters a second. But I'm asked to find the time using my graphs. So what I'm going to do is I'm going to write out what formula would I use. This is some time t. What formula would I use to work out the area? If I was to work out looking for displacement, it's half base times height. But I know the area, that's 30. I know a half. The base is t, the time that I'm going to find. What's my height? Well, that's a bit of a tough one. I've got gradient, I've got how steep it is. For every second, it goes up 10 meters a second. And I know it's going for t seconds. So Let's write it this way. Let's write the gradient equals rise over run. I know what my gradient is, it's 10. My rise is some velocity I don't know, and my run is t. So velocity, if I rearrange that, velocity equals 10 times t. Let's go back to this one. My area equals half base times height. Yes, I know that. 30 meters is my area. Been given that, I'm kind of working backwards. Half times my base is t. That's t, and my height is some velocity v, and I've worked that out already, is 10 times t. So I've got 30 equals a half times 10 times t squared. 30 equals 5 times t squared. Divide both sides by 5. I get 6 equals t squared. And square root, I get t equals, I think, about 2.4 seconds. Next one, use a formula. Find the time to hit the ground and check your answer to D above. So whenever I'm using a formula, the first thing I write out is what I know and what I want to find out. So I want to find out time. I know the initial velocity was 0 meters a second. I know acceleration is positive 10 meters per second. I know displacement equals 30 meters. What formula has all these ones in it? D equals VIT plus half AT squared, but initial velocity is 0, so that disappears. G equals half AT squared. I then put my numbers in. 30 equals, I'm going to rearrange it first before I put my numbers in. So I want to find t, so I'm going to times both sides by 2 equals AT squared. I'm going to divide by a, 2d over a equals t squared. I'm going to square root 2d over a equals t. Then I put my numbers in. So 2 times 30 over a, which is 10, equals the square root of 2 times 30 is 60 over 10 equals the square root of 6, which is what I had before, which is equal to 2.4 seconds. That's the same as before. Great. Number 8, a car whose initial speed is 30 slows down uniformly to 10 meters a second in 5 seconds. So we've got some car that's going along fast, and then after a while it's going slow. So it was going 30 meters a second first, and then down here it's going 10 meters a second, and that took 5 seconds of slowing. Make a well-labeled motion map. So I'm going to go this way for my motion map. My positive, there's my 0. Starts off is quite fast, and then these get closer together. My velocity is getting smaller. Label them, which means my acceleration in betweens must be this way. That means my velocity is positive, and my acceleration is negative. That's how I write positive, negative. Right, draw a position time graph. We start off fast, and we get more and more shallow. My velocity starts off quite high. We go from 30 to 10. So I'm going to say this is 30, 20, 10, and we do that in 5 seconds. 1, 2, 3, 4, 5. So we end up down here. Go away. And we started here. That's a great straight line. You get the picture. Use the graphs to find the acceleration of the car. From my velocity graph, my acceleration is rise over run. And it rises, it goes from 30 down to 10, so it rises by negative 20, and the run is 5. Let's put the units in meters per second, seconds. 20 divided by 5 is 4 meters per second, and that was, negative. So this is this answer here. Using a formula, find the acceleration and check your answer to D above. So I write down when I'm using a formula what I know and what I want first. I want to find the acceleration. Acceleration's question mark. I know my initial velocity was 30 meters a second. I know my final velocity is 10 meters a second. I know my time equals 5 seconds. And a formula that has all those four in it is Vf equals Vi plus At. And I want to find A. So if I rearrange, I get Vf minus Vi over T equals A. Put my numbers in. Vf is 10 meters a second minus Vi is 30 meters a second over T is 5 seconds. 10 minus 30 is minus 20 over 5 equals negative 4 meters per second. Same. Hooray for me. Use your graph to determine the distance the car travels in the third second. The third second is defined as from 2 to 3. 1, 2, 3. How much distance does it travel between here and here? Using my graph, I want to find the area under that graph. So that's a trapezium. I don't know the formula for a trapezium, even with my PhD. So I need to split it up into a I need to split it up into a triangle at the top and a rectangle. So I'm going to redraw it over here. So it was a trapezium, and I'm redrawing it as a triangle and a rectangle. My rectangle is base height. My triangle has a height here and the same base. Well, everything's got a base of 1 because it goes from 2 to 3. That's easy. This rectangle has a height of, oh dear, what's the height? Okay, so we know it goes, the acceleration is negative 4 meters per second for every second. So if it starts off at 30, after 1 second, it's slowed by 4 meters a second. So at this point, it's at 26 meters a second. After another second, it slows by another 4 meters a second. So now it's at 22 meters a second. At 3, it's slowed by another 4 meters a second, so it's at 18 meters a second. Right, so this one here is 22 at the first one, and then it's down to 18. So that's 22, and then it goes down to 18. So this height here is 18. This height here, this little height here, is 4. Because 22 is this height, 18 is this height, the difference is 4. So my area under the graph is a base times height plus half base times height, which is 1 times 18 plus half times base is 1 times height is 4. So that's 18 plus 2 is 20 meters. So let's check this answer with a formula. Do the same thing. How far the car travels in the third second, check your answer. So I know my initial velocity is 22 meters a second. I know my final velocity is 18 meters a second. I want to find out my displacement. I've got my time as 1. I've got acceleration equals negative 4 meters a second. There's so many formulas I could use because I've got usually, like if you look at this question, you've only got 4 things, right? So you're limited on what you can choose. Because I've now got so many things, I can choose any of the formulas as long as there's a displacement in it. I think the one I'm going to use is, I just like this formula. It just looks cool. So I'm going to use that one. Initial velocity is 22 times 1 second plus half times acceleration is negative 4 times t is 1 second squared. So that's 22 times 1 is 22 meters, plus 1 squared is 1, half times is -2 meters. 22 plus -2 equals 20 meters. Same answer as this one. Hooray! I think that's it. It is.